Okay, so our next conic section deals with ellipses. So an ellipse is like an oval, basically. The definition is here: the set of all points, the sum of whose distances from two fixed points is constant. So the way that you create an ellipse, you have two fixed points. Take any two dots at all. So grabbing just a couple of dots, here's a dot, and here's a dot. Now imagine if we were to be able to put pins where those dots are, and then we take a piece of string and we tie it together so it's a circle. Then we take that string and we put it around the two dots loosely, like so. So we have this piece of string like that, okay? Then we take that string and we put our pencil and we pull that string tight. So if we were to put our pencil, say right here at this black dot, we take our pencil, we put it there, and we pull the string tight. Okay, so when we pull that string, remember we have two pins at the blue dots. When we pull the string, it's going to then look like this. It'll hook around this pin, it'll hook around this pin, and then it'll hook around our pencil. Okay, so now we've pulled it tight. Yeah, you got to use your imagination. Distance learning. We're all trying to do this together. And then with the string tight, I then draw and keep that string tight the entire time. And if we do that, we will create an oval. That oval official name is an ellipse. Those two blue dots, we call those foci, focus. Plural of focus is foci, so that's focus 1 and that's focus 2. We go back to the definition. The definition says that an ellipse is the set of all points, so that ring around those two dots, the set of all points, the sum of whose distances from two fixed points is constant. So if I grab a dot, a coordinate on my ellipse on the oval, this dot right here, then the distance from that dot to F1 and that dot to F2, if I call that D1 and D2, if we were to add those distances together, D1 plus D2 is constant. It doesn't change. That distance is 7, and it's always 7, or whatever the value is. Okay, that's what makes an ellipse an ellipse. We know that that distance is constant by looking at how I set up the ellipse. If we take a string, like I said, that string's length isn't going to change just because I pull it tight around a couple of pins. So the length of the string is the same no matter what. So as I spin around the dots, keeping the string tight to the two pins, the two foci, as long as we do that, the sum of the distance would have to be the same. And so that's how an ellipse is created. An ellipse can be horizontal like that, or an ellipse can be vertical. For a vertical ellipse, your foci are, instead of next to each other right and left, the foci would be on top of each other. So we'd have, wow, that was the worst try for a dot in the world. That's a little better. So we've got our first focus there and our second focus there. If we had foci like that, then the ellipse would be a vertical ellipse, longer going up and down than left and right. Okay, and so we have those two different ellipses, and we're going to get two different equations, just like we did with parabolas, and we'll see those equations next. A couple other things that we have when it comes to an ellipse. I'm going to come back to the horizontal ellipse that I have here. We have two different axes. We have a major axis. The major axis goes completely through the foci. The major axis always goes through the foci. But we also have a minor axis. The minor axis does not go through the foci. The minor axis goes like that. That's our minor axis. Both the major and the minor pass through the center of the ellipse. So I'll put the center in purple. That's the center of the ellipse. Okay, so we have foci, we have the center, we have the major axis, we have the minor axis. Where the major axis ends and starts, this dot here and this dot here, those are the vertices. Running out of room. Those are the vertices of the ellipse. The vertices of the ellipse are always at the end of the major and at the end of the major axis, not the end of the minor axis. So a lot of different vocab, a lot of different words, and we're going to see how those are used in the standard form. So let's move on to the next slide and take a look at the standard form of an ellipse. All right, so standard form of an ellipse, again, like magic. Horizontal and vertical, two different ellipses. So I drew a little picture of what a horizontal would look like. It just means that the major axis, it's longer than it is tall. For a vertical, it's taller than wide. Notice the two equations. They look very, very similar. In fact, almost everything is the same about them. The only difference between horizontal and vertical is in the horizontal ellipse, x minus h squared comes first, and in a vertical ellipse, y minus k squared comes first. So it's addition, so you might think, well, can't I just put them in any order? So how do I tell whether it's horizontal or vertical? In both instances, let's make that look better. In both instances, A must be greater than B. A cannot equal B. If A equals B, then the denominators would have the same number. And what I could do then is I could multiply both sides by that number, and that would make the denominators totally disappear, and we would end up with an equation of a circle. That's what happens when A equals B. So we can't have A equaling B. We don't have an ellipse then. We have a circle, which you could think of a circle as a special kind of an ellipse, just like a square is a special type of rectangle. For an ellipse, you have the equation equaling 1 because A and B are going to be different. So I couldn't multiply by something and not have any numbers in front of the parentheses or anything like that. And so we end up with this standard form. Basically, once you get into standard form, then you can determine whether you have a horizontal or vertical ellipse. You just look at the denominator, and whatever denominator is bigger, that needs to be first. And so you just change the order of your sum. No big deal. Some other information on what A and what B are. A is the length, is half the length of the major axis. Ooh, let's get an actual marker. There we go. Okay, so A is half the length. I missed the word the. Half the length of the major axis. And then B, you guessed it, B is going to be half the length of the minor axis. And so that's why A has to be bigger than B, because A specifically deals with the major axis. If B were bigger than A, then that wouldn't be the major axis, and that would be really weird. So I'm just going to use these quotes, half the length of the, instead of major, minor axis. And so that's what A and B will give us. H and K, that is just like it was with circles and just like it was with parabolas. H and K had a meaning. H and K is going to be the center of the ellipse. And then we have one other thing that we can calculate from A and B. Now, if we had time in class, we would go through this. I would diagram this out. We'd see exactly how this works. But I only have 15 minutes on every video, and we've got lots of stuff here with ellipses. And so I'm just going to jump to this. We have a C value. It's not in the equation at all, but we can calculate C. It comes from the Pythagorean theorem. It looks like the Pythagorean theorem with one tiny little difference. A squared minus B squared ends up equaling C squared. Now what C is the distance from the foci to the center. Distance, there we go. From either focus, because they're both going to be the same, so it's the distance from either focus to the center. That's going to help us figure out coordinates when we get there with examples in our next video. So with the equations, we get A and B, we get H and K. We have to calculate C if we need it, which we'll see in a second, and there's all our information. The vertical and the horizontal work exactly the same way. All this information is the same depending on whether you have a horizontal or vertical. It's just the order in which you write it. Again, A has to be bigger than B, so if X comes first with A being bigger in the denominator, it's a horizontal ellipse. If Y comes first with A being the biggest denominator, then you have a vertical ellipse. So we're going to take a look at one quick example, and then we're going to do a bunch more in the next video. So let's move on to the next slide. All right, so again, like magic, write the equation of the ellipse with foci at 0, 1, and 4, 1, and the length of the major axis is 6. So we have our foci. Our foci don't work in our equation at all. The length of the major axis is 6, so knowing that the length of the major axis is 6, that's going to get us a piece of information right away. Since the length of the major axis is 6, that tells us that A must be 3, because A is half the length of the major axis. I'm going to go ahead and put a box around that. That's some information that I'm going to be needing when it comes to writing the equation, but there's lots of stuff that I'm missing. I don't know the center, so I don't know H and K. I don't know the length of the minor axis, so I don't know B. There's all that stuff that I have to still try and figure out. So I'm just going to keep A there because I know that's a fact and just kind of put it on hold. Next, something that I didn't mention in the last slide, where the center is. Let's go back to the original picture, the first slide. That center, that purple dot, which is right here, that purple dot, that center, that's halfway between the two foci. This distance from the center to focus 1, is the same as the distance from center to focus 2. So, jumping back to this problem, because the center is in the middle of the foci, and I have the two foci, I can find the midpoint of the foci. If you recall, to find midpoint's super duper easy. You just add the x's and divide by 2, and then you add the y's and divide by 2. So 0 plus 4 divided by 2, and then we'll add our y's, 1 plus 1 divided by 2. And if we do that work, 0 plus 4 is 4 divided by 2 is 2, 1 plus 1 is 2 divided by 2 is 1. That's where the center of our ellipse is. Let's try that again. Center. That's a little better. The center of our ellipse is at the coordinate 2, 1. That tells us H and K. That's big information as well. So now I have H, I have K, I have A. All I need is B. Once I have B, I'll have everything. I also need to figure out whether this is a horizontal or vertical. We haven't done that yet. So let's do that next. How can I tell if this is a horizontal or a vertical ellipse? Well, you just kind of have to think about if you were to graph this. If we were to draw a quick graph, our foci is at the coordinate 0, 1. So that's that coordinate right there, and then 4. Nope, that's not that coordinate right there. I can't believe I did that. 0, 1 is right there, and then 4, 1 is right there. So since those are the two foci, they share the same y value. They're directly across from each other, so the major axis would go like this, which means we have a horizontal ellipse. Okay, so let's get rid of all that nastiness because that was not done very well at all. But now we know that it's horizontal, so I know that x is going to come first, and then y will come second. So now we just have to figure out what b is. Well, from what we saw on the last slide, let me jump back to that again. We can see that c is the distance from either focus to the center. As well, we also see that c squared is equal to a squared minus b squared. So, utilizing that information, I can come over here and I can go ahead and I can find b, or I can find c. I know the center is at 2, 1, and the foci are at 0, 1, and 4, 1, so the center is 2 away from the foci, so that means that C must be 2. I'm going to kind of box that one a little bit, just like that, because that's not information for my equation, but that is information that I'll need. Now that I have C, I can figure out B, because C squared is equal to A squared minus B squared. And so if I do that work, 2 squared, which is 4, is going to equal 3 squared, which is 9, minus b squared. That tells us that b is the square root of 5. That's important information as well, and that will lead us to the equation. So now I can write my equation, x minus h, which is 2, squared over a squared, 3 squared is 9, plus y minus 1 from the center, squared, over b squared. B is the square root of 5. If I do the square root of 5 squared, it's 5, and that will equal 1. And there's the equation of our ellipse. Our next video, we'll do more examples of this and putting it into the form, doing more completing the square and all that. So until next time, have yourself a great day, stay safe, and stay healthy.